Welcome to Utah Lake Sat in a Wall. Utah Lake had a great fall, how to put the lake back together again. With us today we have David Richards. Dave is a lake whisperer with OreoHelix Engineering. So with that, Dave's going to have about 30 minutes. Thank you, Dave.
All right. Can you guys hear me okay? Because I got a soft voice. So Utah Lake Sat in a Wall, it's kind of like the takeoff on Humpty Dumpty sat in a wall, if you're all familiar with Humpty Dumpty. The story is Humpty Dumpty sat in a wall, Humpty Dumpty had a great fall. All the king's horses and all the king's men couldn't put Humpty Dumpty back together again. It was kind of a nursery rhyme about some of the kings back in England, or it could be about an egg falling off the wall. So it's all kind of this theme for what I'm going to be talking about today. The other theme I'm going to be talking about, part of this, is that November is Native American Indian Heritage Month. It was 1990 bill passed by Republican President George H.W. Bush. So it's going to be a little bit about Native American history and Humpty Dumpty's falling off the wall. So the first fall was Lake Bonneville becomes Utah Lake and Great Salt Lake. So if we're all familiar with what Lake Bonneville was about 14,500 years ago or so, Lake Bonneville had it flooded. The dam broke. Let's see if I get the pointer. This dam up here, Red Rock Pass. All of this was Lake Bonneville. Folks yesterday were talking about the Great Salt Lake Basin. Actually, it's the Lake Bonneville Basin. And so the water flooded through this break and went down the Snake River out to the Pacific Ocean. And it took about a year for this flood to happen. So what we're thinking now is that some of the ancestors of the Timpanogos tribe that used to live on Utah Lake might have actually witnessed this flood. So I can imagine if you're sitting on the shore of this lake, little Utah Lake here, that you witnessed this flood, the whole lake draining in a year. That'd been pretty incredible. So what I like to call Utah Lake is Little Upper Lake Bonneville, and Great Salt Lake is Lower Lake Bonneville. Or now we're calling Utah Lake Timpanogos Lake. Some people are calling it Timpanogos Lake in honor of the Timpanogos Native Americans and Mount Timpanogos that sits alongside Utah Lake and causes a lot of the weather. So the second fall was the management overthrow of Utah Lake. So the old management was the Timpanogos tribe that lived along the shores, and we could call them the Center for Holistic Ecosystem Management. And they were here since time immemorial till around 1849 or so. But then the new management came in, the white colonizers. We could call those the Manifest Destiny Incorporated. So they're still going on till present. Some of the things that the old management team did, they were all about sustainability, natural water level regime, maintain the native biota. They used the native biota, but they maintained it. There was limited human waste going into Utah Lake from the natives. And the only introduced species I could think of was maybe the horse that they brought in. If we're looking here at the new management administrative acts, diversions, loss of connectivity, less water, urban development, urban industrial runoff, unnatural water level regimes. All these have a big impact on Utah Lake. Extirpation of native biota, the fish, the plants, the mollusks. The humans, they extirpated the humans, the Native Americans from here. Pollutants, all the pollutants they put in there, you put strychnine in the water to help get rid of the Native Americans as quickly as possible. Overgrazing watershed. All the pollutants that we have are still there. Oil products, PCBs, heavy metals, nutrients, human waste. And then another big thing that we're concerned about is the introduction of invasive species. And we got a whole list of invasive species: carp, catfish, white bass, walleye, fathead minnows, mosquito fish, black crappie, we got sunfish, a couple of species of sunfish. Asian weatherfish is probably in there now. European Phragmites, emphasize the European because Phragmites is native to Utah Lake, and African salt cedar with tamarisk, and Russian olives too. So these are all the different management strategies for the past and present. So this slide is a little bit complicated to understand. It's called stable ecosystems or stable steady states. And in the past, the stable steady state of Utah Lake was clear native aquatic plants and mollusks, balanced fishery, ecosystem functioning properly. And so you could liken it to a canoe. If you're paddling along, you're pretty stable, but then you come to this tipping point. It's either from adding nutrients or carp or whatever perturbation you can think of. So you go along this gradient, and all of a sudden, like if you're leaning over in canoe, you get to this tipping point, and all of a sudden you flip over, and you're upside down and going down through a rapids into some nice boulders and stuff. So this is a stable state that Utah Lake is in now. It's turbid. It's got harmful algal blooms, loss of the native biota, poor ecosystem function. So it has gone under what we call ecological hysteresis, which means going back to this state is going to take a lot more effort than what caused the tipping point in the first place. So for instance, if it was 0.1 milligrams per liter of phosphorus, to get back up to this steady state, you might have to go way down to almost zero phosphorus, or get carp down to 6 tons per square meter, things like that. So that's an important thing to know. If you understand this, then you could talk to anybody about the ecology of Utah Lake is the steady state ecosystems and tipping points and hysteresis. So Utah Lake continues to be abused and mistreated. Utah Lake Authority now preaches that Utah Lake is the most beautiful lake in the world, and let's make Utah Lake a world-class recreation destination. So now if we're going to make this the most beautiful lake in the world, how are we going to do this? Or if we want to make it a world-class recreation destination, how are we going to do this? So the analogy here is Humpty Dumpty was an egg, so I guess the best thing to do is think about making some kind of omelet. So now we get to the ecological science, the ecological restoration requirements. We come up with a few actions that we need to do to restore Utah Lake somewhat back to what it used to be, or high quality omelet or something like that. And so they have to be done concurrently, synergistically. And the first one would be sediment stabilization, carp reduction, balanced food web and fisheries, nutrient utilization, reintroduce the native biota, and reduce turbidity. This is all positive feedback loops. So if you do them all these at once, try to do them all at once, they'll work together to help restore Utah Lake. So let's start with sediment stabilization. Sediments, if you stabilize the sediments, you're going to reduce the effects of wave action and reduce carp and other native bioturbators. So that's one way to reduce this, the sediment flux. And you manage the lake fluctuation more naturally. And remember, Utah Lake is a lake, it's not a reservoir. We should manage it as a lake. We have to keep water coming into it as much as possible. Let's manage it as a lake and not a reservoir. So biological stabilizers would include your aquatic vegetation, clams and mussels, and benthic algae. Benthic algae are important. If you get light penetrating down into the sediments, you're going to grow benthic algae in these guys, and they're going to stabilize the sediment, and they're going to help compete with the algae to clear up the lake. And the native mussels and snails were important part of the whole ecosystem when they're all but been lost. So this has been being done all over the world. Here's an excellent paper publication to read. It's about restoring shallow lake ecosystems in the Netherlands, and we're following pretty much exactly what they're doing all over the world. It's nothing new. Carp, of course, we call carp the #1 problem in the lake, along with invasive Phragmites. But there's all those other species of introduced fish that I talked about also are a big problem, but carp are the #1 problem. So they were originally introduced into Utah Lake in the 1880s or so, and that was by the Utah Fish Commissioner Milton Musser. And we have to remember that a lot of people think that a lot of the managers say, well, like to blame it on the federal agencies for bringing carp into Utah Lake, but it was actually the Utah Fish Commissioner that put the Utah Lake with carp into it. But remember, back in the 1850s, the whole nation was carp mania. Everybody was into carp, saying we're going to put carp all over the world, and they're going to be the food for everybody to eat. Our tastes have changed, and no one really in Utah likes to eat carp anymore. The problem with carp is they uproot native aquatic plants and mollusks. They're a major cause of the turbidity, and about 90% of the total fish biomass in Utah Lake is carp, and they consume vast quantities of zooplankton and vertebrates. And Utah Lake is carp heaven. It used to be called sucker heaven, but now it's called carp heaven. So They're a big problem, but we could figure out how to manage those guys a little bit better. The next one would be turbidity. And what the deal with turbidity is that right now the sediment gets stirred up so much that it's highly turbid. It doesn't let the light penetrate to the sediments to grow benthic algae or macrophytes that would compete with the harmful algal blooms. And we want to get light to penetrate as far down into the sediments as possible. And one of the remedies you could consider suction dredging. People don't like to talk about dredging in Utah Lake, but suction dredging might be an idea. Reduce the wave action and bioturbation and stabilize those sediments, and you'll reduce sediments, you'll reduce the turbidity, you'll get light penetrating to the bottom, and you'll have much better ecosystem. Restore the native biota. That includes the mollusks, the fishes, and the aquatic plants. And our mollusks are snails, clams, and mussels. And originally we had about 17 species living in Utah Lake. Now we have 2 or 3. And it was truly a unique molluscan hotspot in the western U.S. The western U.S. is pretty depaupered of mollusks, but Utah Lake is one of the best places that mollusks ever lived in the western United States. So that's a really unique hotspot for western USA. And they did a great ecosystem services to keep the lake functioning properly. So examples of that, they likely occurred in Utah Lake by the millions. These are Margaritifera falcata. They're not from Utah Lake, but you can see if the beds were like this in Utah Lake, how much they would stabilize the sediment. They would filter out the water. These are great water filters. They probably filtered the entire Utah Lake every week or 2 or 3. So just imagine all the water going through these clams and mussels. And so if you have example here, in 3 or 4 hours, you go from this to there. If you put a couple mussels in there. Here in 20 minutes, you put some clams in there, and the water goes from this to that just in 20 minutes. So they're actively filtering out the water, stabilizing the sediment. It's essential to return these natives back into Utah Lake. Our native fishes had a diverse assemblage, balanced fishery. Here's all the native species that used to live in Utah Lake. Some of them still occur. Utah sucker is still there. And our threatened June sucker is the most common native right now. And that's because we spent millions and millions of dollars to protect it and reestablish populations. But all these other species used to be functioning in the lake. They're pretty much no longer there. Utah chub might show up a little bit too. Bonneville cutthroat trout, of course, no longer live in Utah Lake, but they live in some of the headwater drainages. So an example of fisheries management, we've got the Lahontan cutthroat trout over here and the Bonneville cutthroat trout over here. Lahontan cutthroat trout get to be really big, as did the Bonneville cutthroat trout. And Lahontan cutthroat trout were native to old ancient Lake Lahontan, which is now the remnants are Pyramid Lake and Lake Tahoe. But we have different management strategies for both of those lakes and for Utah Lake. The management of Pyramid Lake is by the Native Americans, the Paiute tribe, which is closely related to the Timpanogos tribe that used to live on Utah Lake. And they still have cutthroat trout, and they're doing pretty well. The Lake Tahoe, you're probably all familiar with Lake Tahoe, that's non-native folks with multiple agencies managing the lake. There's no longer Lahontan cutthroat trout in Lake Tahoe. They're trying to reintroduce them, but it's going to be hard because they introduced so many other salmonins in there. And once again, Utah Lake is now managed by multiple agencies, and there's no longer Bonneville cutthroat trout. So the question is, do Native Americans, are they better able to manage ecosystems? Should we include them at the table when we're talking about managing Utah Lake? I think the answer is yes, why not? They know a lot of things that we don't know. Native aquatic plants. There's some limited success so far. A lot of folks are trying to reintroduce native plants to Utah Lake. They stabilize the substrate. They provide habitat for small fish, zooplankton, other invertebrates, and birds. And they outcompete the phytoplankton for nutrients. A lot of people don't think about that. And they improve the food web and the ecosystem. But I'm trying to remind everybody that Phragmites is native to Utah. Here's the distribution of native Phragmites, and it occurred in Utah for tens of thousands of years. Here's some folks over here in North Dakota. This is an 1860s photo of someone harvesting Phragmites. So Utah, the word Utah comes from the word reed for U, and ta is arrow. So the word Utah actually comes from Phragmites as the reed that used to be here. And you can look up this, these guys here that are trying to restore native Phragmites to the Great Lakes, not Great Salt Lake. So remind everybody that Phragmites is native, but the invasive subspecies is a big problem. We have to control that, but still try to maintain the native Phragmites, because the Native Americans used the native Phragmites for food, for medicine, for shelter. They built their houses out of it. They used it for clothing and a whole bunch of other uses. So it was extremely important to the Native Americans that lived there. Nutrient reduction and utilization. We all talk about reducing the amount of nutrients coming into Utah Lake, but I think we're right at the point we're not going to be able to reduce too many more nutrients, and it's better to start utilizing the nutrients. So here's a little pie chart I did a few years ago, where basically the nutrients coming out of the sediments are we're talking about total phosphorus right here, is pretty close to 85% of the nutrients in Utah Lake's water column comes out of the sediments. It's trying to balance itself in equilibrium, so the sediments provide nutrients into the water column. Atmospheric deposition is probably around 8%, or 150 to 200 tons of phosphorus falls onto Utah Lake every year. Wastewater treatment facilities are about 4%. The tributaries and the stormwater runoff are about 2%, and we've got about 20 tons leaving Utah Lake down the Jordan River. So if we manage this ecosystem properly, the nutrients will be better able to be utilized, and we won't have such problems. And that's this little diagram here. So if we have the macrophytes, the plants, the submerging, emerging aquatic vegetation, and they're taking care of some of the stabilizing the sediments. We've got the little snails grazing on the epiphytes. We've got all the fish in here, and we've got benthic algae growing on the bottom, stabilizing the sediment, competing with the phytoplankton for nutrients, and we get a more balanced system. So if we could actually utilize the nutrients that are in Utah Lake and maybe get it more towards a clear water state. So one thing I'm very concerned about is we all say we're doing things to restore our ecosystems like the Great Salt Lake or Utah Lake. We're spending millions and millions of dollars, but how do we know we're having an effect on the ecosystem? And so we want to measure our success. So if we're not measuring what the impacts are from our restoration efforts, we really don't know whether we did anything. We could say, well, we spent $800 million on a new treatment facility, but does that have an effect on the ecosystem? Or whatever we did, is it really actually having an effect? You have to go out there and monitor it. So that's critically important. And what I like to do is follow this international ecological restoration standards. So it's a little wheel you do before and after, and you could figure out what's going on, whether you had an effect. Or we're also developing a multi-metric index of ecological integrity, which includes really easily measured metrics, including zooplankton and fish species. And both of these respond quickly to restoration efforts. So these guys are good monitors and metrics to use to measure our success. And finally, we're developing a food web ecosystem function model of Utah Lake. This is our first draft model of what's going on in Utah Lake. And this model will help us better manage the lake as well. This is what the food web kind of looks like in Utah Lake. It's complicated, but it's not that difficult to measure, but we just need more data. We're also doing this for Farmington Bay of Great Salt Lake, and the idea is that if we measure what's going on, we could use these models to help us better determine whether we're successful or not, or what we can change, what different management strategies we could do. And so that was the end of my talk. If we have any questions or comments, I'd be glad to take them. Oh, there's a test. All right, you ready? You got 2 seconds. What do carp eat? Everything. Right? So carp are pretty much a top-down control on everything. So they pretty much eat everything. They disturb the sediments. They eat the macrophytes. They eat the mollusks. They eat all the wonderful midges that live there. But there's also bottom-up controls of carp too, right? Because all those little, like the white bass and all those other fish, eat the baby carp, and the macrophytes, if you have, the macrophytes provide habitat for carp spawning, so there's bottom-up controls for carp as well. They're not just a top-down control on the ecosystem.
Phragmites were always here. How do you know when you've got the right balance? Right? What percentage did you have around the lake?
100%, right? 100% native Phragmites, if you want it to be what it was in the past. But that's probably not going to happen because the new version of Phragmites is a lot more invasive. But remember, the Native Americans harvested Phragmites like crazy. That was part of their culture. And so they controlled how much Phragmites was out there. And so maybe it was because they're harvesting so much that it allowed for the new invasive species to come in. I'm just making this up. But if you want natives back there, why not get 100% native Phragmites? Because they're beautiful. If you go down the Colorado River or Fremont River in Capitol Reef, that native Phragmites is really cool and wonderful.
David, what's keeping the mussels out? Like, is carp the biggest limiting factor for mussel reestablishment?
What we have in Utah Lake is really much one species of mussel. It was called Anodonta californiensis nataliana. And it was pretty big. It was a big mussel, right? It was this big. And the thing about the life cycle of that is that it needs a secondary host. So it releases these little larvae called glaucidia that attach to fish's gills. And they hang out on the fish's gills, get some nutrients from the blood flowing through the gills. They just hang on there for a week or two or a month. Then they fall off as little baby mussels. So they need a certain specific secondary host. We're not exactly, they're pretty much generalists for their secondary hosts, but carp, they just don't do well on carp. And carp like to eat these little baby mussels because their shells are so thin. So carp are great molluscivores. They'll just gobble every little clam and snail and mussel that they find. So carp are a big problem. What the natives, maybe we get the Bonneville cutthroat truck back out there, or the June suckers, more June suckers, and then maybe we'll be able to reintroduce those mussels back to the ecosystem. Yep.
I have two questions. First, what's your favorite carp recipe?
I like to bake them on alderwood.
Second, why single out native Phragmites as opposed to some other plant?
Kind of like the bulrush, like the bulrush or something like that. I'm not sure why I'm saying that, but Phragmites were so important because they were they're known as reed people, and they made the reed arrows at it. And they used it for building their materials and for their houses and their food. So, and it's a great source of protein for their horses, right? Little baby Phragmites has more protein, I think, than alfalfa does. So it was great for everything. And it probably needs, I think the question this lady was asking was, how much Phragmites? 100%, I said. Not 100% of all the native other plants, but compared to invasive Phragmites, should be 100% native and 0% invasive Phragmites. Okay, thanks.